Hi, in this video we'll be talking about a fourth type of reactions, that is a double replacement reaction. And there are two types, formation for precipitate and acid-base neutralization. So what is a precipitate? A precipitate is solid, liquid, or gas. In other words, if a precipitate is not formed, then no reaction. So we have aqueous plus any double replacement, the reactants is almost always aqueous. So aqueous plus aqueous yields, let's say, aqueous and solid. Then that means the reaction does occur. But if it's two aqueous, then that tells us there is no reaction at all. So we just write no reaction. And RXN is an abbreviation for reaction. We're going to be using more of this later. So let's do our first example of iron 2 oxide and potassium chloride. Alright, so iron 2 oxide is FeO, and all oxides are aqueous. Oh no, everything in double replacement, the reactants is always aqueous. So it's aqueous plus potassium chloride, KCl, aqueous, yield what? And in double reaction, this is how you identify the products. You're going to use the outer ones. Nope. The outer ones are going to come together, and the inner ones are going to come together. So the Fe is going to come together with Cl, forming FeCl2. Why they added 2? Because it's iron 2 oxide, and with a charge of 2 plus, and Cl only has a charge of 1 minus. So FeCl2, and our insides got to come together as well. O and K got to come together, plus K2O. Again, I added 2 because oxide is 2 minus. Now we got a balanced equation, right? We have 2K and 2Cl. So all we have to do is add a 2 over here, and let's identify if this reaction occurs or not. So let me add more space, plus K2O. Again, all oxides are solid except for group 1A. Group 1A always aqueous. K is in group 1A. So that makes this are aqueous. FeCl2, all chlorides are aqueous except for group 2A, except for silver, lead, and mercury. Although this is lead, but no, okay. So all chlorides are aqueous except for silver, lead, and mercury. This is iron, so that means it's not an exception. This will always be aqueous. As you can see, both of the products are aqueous, and that means there's no reaction. And that's that. So our second example of type A. Alright, both of these are type A. We're going to talk about type B after this. Alright, our second example will be ammonium phosphate and silver nitrate. So ammonium phosphate is NH4 times that by 3 because PO4 is 3 minus. Now this will be aqueous plus AgNO3 aqueous. Now what does this yield? This yields, alright, so the outsides come together and the insides comes together. So NO3 has 1 minus while NH4 has 1 plus. So it's going to be H4, NO3, these two are already balanced. Since there's 3 over here, we're going to have to add a 3 over here, which makes this balanced out. And our insides come together, which is Ag plus PO4. Ag1 plus PO4 3 minus, which is why we need a 3 over here as well. Nope. Ag3 PO4. Now we got to balance the equation, right? NH4 times that by 3, check. PO4, check. NO3 times 3, oof, that's 9. So we're going to add a 3 over here, which makes this 3 as well. So now this is balanced. And what do we have here? NO3 is nitrate, right? And I'm pretty sure all nitrates are all ammonium and all nitrates are aqueous. So this one's aqueous. And next I have Ag3PO4. PO4 is phosphate. Now phosphate states all phosphates are solid except for group 1A and ammonium. Ag is not in group 1A and it is not ammonium, so that means this is insoluble, aka solid. Is there a solid, liquid, or gas, aka precipitate? Yes, there is. So that means there is a reaction in the second one. Alright, now our second example, our second type about acids and bases. We have nitric acid and potassium hydroxide. Nitric acid is HNO3, nitrate, HNO3 aqueous, plus potassium hydroxide, KOH, aqueous. That makes the outsides come together. OH will come with the H. OH will come with the H, which forms H2O, 2H and 1O, and plus the K and the NO3 will come together. KNO3. Alright, everything is balanced. Let's see if this reaction will occur now. So first of all, water is a liquid, and that automatically makes this reaction occur. So we need to determine the state of matter for KNO3. NO3 is a nitrate, and all nitrates are aqueous except for group 1A. Oh wait, whenever you see group 1, I made a mistake. Whenever you see group 1A, you don't even need to think twice before knowing it's aqueous. So whenever you see group 1, you know this is aqueous due to the K, which is in group 1. So now we have our final reaction over here, and we have identified every single state of matter. At this point, you should be able to identify every single state of matter in any equation. Thank you for watching.